In this video, we want to look at the ChangeMaker app. So we want to write a method, public static void make change. It takes in a double for the amount you paid, and it takes a double for the cost of the items that you chose. And this will make change given the amount of bills or the cost and the amount the customer handed the cashier, how much you paid. Your method should calculate the number of bills and coins that should be returned to the customer. Use the following denominations. So $20 bill, $10 bill, $5 bill, $1 bill, 25-cent piece, a quarter, a dime, a nickel, and a penny. So we're going to use a greedy algorithm. We're basically going to subtract the largest denomination possible each time from the amount of change to make. To keep the change-making procedure precise, keep everything in integers. So we're going to switch everything to pennies so we don't have to deal with decimals. The reason for this design decision is the floating point number values like double are imprecise and subject to rounding errors. For the recklessly curious, see this link. Your method should produce an output that looks like this. So given that you paid the cashier $20 and the cost of your items was $13.44, that's a difference of $6.56. So that the $6 would be made of a $5 bill and a $1 bill, and we'd get to 56 cents with 2 quarters, a nickel, and a penny. So let's go to the whiteboard and see how we might visualize this problem. So I'm going to do it with a couple of arrays. So up here in the top in orange, I've written the denominations: $20, $20 bill, $10 bill, $5 bill, $1 bill, and then quarter, dime, nickel, penny. And I'm going to write this, I'm going to work in terms of pennies or cents. So the $20 bill is just 2,000 pennies, 1,000 pennies for the $10 bill, etc. So by putting all the denominations into an array, I can iterate through them, and they are a sorted order. So I want to start at the first denomination, the largest possible one, and see if how much change I can give in $20 bills before I consider giving any change in $10 bills, etc. And this should work out nicely because this set of denominations is intuitive, and a greedy algorithm will actually give us the optimal algorithm or optimal solution. I'm also going to create a parallel array called count, and this is going to start with zeros, and it's going to be the same length as denomination, but for example, if I pay any $20 bills, I'll increment this value from 0 to 1. If I pay out any $10 bills, I'll increment this one to 1 as well. So let's look at this problem. I've written the problem over here on this side of the screen, and let's look at just how we might give change for $6.56. So if I start off with $6.56, I'm going to write this in terms of pennies, so 656 pennies. Can I give any $20 bills for this? Well, no, that's too big. So then I'm going to move along to this one. Can I give any $10 bills for change? I can't. Can I give any $5 bills for change? Yes. So what I'm going to do is subtract the 500 pennies from this, from what we owe. So we get 156 pennies remaining to go. And I'm going to change this from a 0 to a 1. Now, can I reduce the amount we owe by using any more $5 bills? Well, we can't. So that means that we need to look at the $1 bill. Yes, I can pay out $1 bill. So we reduce that amount, and I'm going to take this up here. So we have 56 cents remaining, and we're going to mark that we added a $1 bill. Now we have to move on to quarters. So can we make quarters? Any quarters for change? So yes, we can. We can actually use 2 of them. And so, but you can increment one at a time. So we're going to subtract 25, and that leaves us 31 cents. And that will increment, we're going to leave that one up there. We're going to increment to 1. We subtract 25 cents again, and that leaves us with six pennies left to go. So we're going to increment this one again. So this is going to be 2. Now we can't get any dimes in there. We can't use dimes at all, but we can use nickels. So I'm going to bring this, whoops, I used the right pen color. So from 6, we're going to subtract a nickel. And we'll count the nickel. I can't use any more nickels because we end up with a penny, but I'm going to look at the penny and we'll add a penny and we'll subtract a penny over here on our math. And we'll end up with 0. So this is how you solve this type of problem, and let's go ahead and code it. First thing I'm going to do is add the array for the denominations. Okay, then I'm going to add the array for counting the coins I'll use for each denomination. These are parallel arrays, so we want this array to be the same length as the denomination arrays, so I'll set its length equal to that, the length of denom. And remember that this has default values. All the default values for all the elements are 0s. And so that's the state that we want to start with. Next, I would like to calculate the amount of change that I owe somebody, and this is going to be measured in pennies. And I will cast it to an integer so I can work with integers. So I'm going to do the subtraction. So paid minus cost. And then I need to scale this by 100, and it's important to scale it by 100 before you cast or you'll get the wrong answer. And let's just print out the value of change so we can at least test that we're getting the right number of pennies that we have to return before we start looking at the coins. So I've added the make change call in main. And we're looking for 656 pennies. So far, so good. Let's keep going. So I need to loop through, I need to write a loop to keep reducing the amount of change that we have until there's no change that I need to do anymore. So as long as the change is greater than 0, we'll keep trying to look for ways that we can return change to this person. And the way we're going to do that is we're going to iterate through the denominations. And so I'm going to just use variable d to go through the denominations. And it starts at index 0. And inside, we would like to consider if the amount of change that we have, if the amount of change that we have is greater than the denomination that we're looking at, then we really need to reduce the change by that amount. And we also have to count that we have to increment our count that we did provide the coin or dollar bill at D. And so we are going to increment this array as shown. So this loop will terminate when the change that we owe drops below the denomination. And actually, we want this inner loop to be greater than or equal to the denomination. Because if I owed you exactly $5, then I would want a $5 bill, right? So that'll keep, this inner loop will keep running while the denomination I happen to be looking at can still be used to reduce the change. Now, once the inner loop is finished, I can't look at that particular coin or bill anymore. I have to move to the next coin or bill. So we'll increment D so D can iterate through the denominations. Now, if we look at the smallest denomination, we know that we could just keep giving out pennies until the change goes down to 0. So we know that for certain that we'll eventually end up owing 0 amount of change. So that's what this loop is for. It'll just keep working until the change is reduced. And we're confident that we will get to a state of 0. So just to see where we're at, let's go ahead and print out our array of coins. And I'm going to print both the denominations as well as the count, just so that we can see them side by side. So this tells me that we're going to give a $5 bill and a $1 bill. That gets us the $6 that we owe. And then 2 quarters, a dime, and a penny will sum up to 56 cents, which is what we owe. So this is the correct answer, but it's not in the correct format. So that's why we need to go back and look at how the outcome is supposed to be formatted. So let's go to ChangeMaker app here. I'm going to go back to the lab document and just look at how it's supposed to be formatted. Because the formatting is unique for each one, I don't see a reason to try to do it using a loop. So I'm going to hard code 9 lines here. So our string is going to be $20, colon, space, space, concatenated with the count at 0, because 0 corresponds to 20. And just to speed this up, let's take care of all of the bills. That will be in the form of dollars. If you want these to line up nicely, you can add additional spaces. So this is index 1 for the $10 bill, index 2 for the 5, index 3 for the $1 bill. Put in a little spacer to separate, and then 25 cents concatenated with count at index 4. And we'll do this for dimes, nickels, pennies. Okay. I'm going to run this again. We're going to look at the output, and we're just going to make sure that we're providing the right types of coins back. So we owe $6.56, so there's the $6, and here is the 56 cents. So this is finished.